Hi everyone, how are you all? I hope that all of you are doing amazingly great. I am back with a new classes for you. Today's class is very important class for both Bengali medium and English medium student. In this class, we will solve the previous year question paper. Okay, so please note all the speech and question answer. Today, we will solve the math problems from the relation and function chapter. If you want to know about this chapter, you can see our previous classes. You can find our previous classes in the description below. So let's get started. Question number 1, it is given that, please follow this. Let A is a set which contains 3 elements, 2, 3 and 5. Be a non-empty set. Okay. Find the total number of reflexive and symmetric relation 1A. We have to find the total number of reflexive and symmetric relation. We know that the total number of reflexive relation is 2 to the power n square minus n. Okay, 2 to the power n square minus n, where n is the cardinal number of the set F. What is cardinal number? Cardinal number here, the cardinal number of A is here, the cardinal number of A, that is Na, is 3. Okay, 1, 2 and 3 elements. So the cardinal number A is 3. The total number of reflexive relation is 2 to the power n square, that is 3 square, minus 3, that is 2 to the power 9 minus 3, okay, that is 2 to the power 6, that is 64. Hence, the total number of reflexive relation is 64. Okay. Now, we know that the total number of symmetric relation is 2 to the power n into n plus 1 by 2, where n is the cardinal number of the set. Here n is equal to 3. So, the total number of symmetric relation is 2 to the power n into n plus 1 by 2. So, 2 to the power 3 into 3 plus 1 all divided by 2 is equal to 2 to the power 3 into 4 by 2 is equal to 2 2s are 4, 2 2s are 4 and 2 3s are 6, 2 to the power 6, 2 to the power 6 is equal to 64. Hence, the total number of symmetric relation is 64. Okay. Next, the question number 2. It is given that if R set up all x, y such that 2x plus y is equal to 8 is a relation on the set of natural number. Okay. We denote the set of natural number this. Write the domain and the range of R. Okay. It is given that the relation R set up all x, y such that 2x plus y is equal to 8. We have to find the range and the domain of the relation R. Okay. For all x, y belongs to R, which implies that 2x plus y is equal to 8. Okay. Then we can find y is equal to 2x, 8 minus 2x. Now we have an box. If we put x is equal to 1, then it becomes 8 minus 2 on the 2, that is 8 minus 2 is equal to 6, which belongs to the set of natural number. Okay. If we put x is equal to 2, then it becomes 4. 8 minus 2 2s are 4. That is 8 minus 4 is equal to 4, which is belongs to natural number. And if we put x is equal to 3, then it becomes 8 minus 2 3s are 6. That is 8 minus 6 is equal to 2, which is belongs to set of natural number. And if we put x is equal to 4, then it becomes 8 minus 2 4s are 8. That is 8 minus 8 is equal to 0, which is not belongs to the set of natural number. We know that 0 is not a natural number. Okay. Hence, we have the relation R is equal to 1, 1, 2, 6, 2, 4, and 3, 2. Then the domain of R is equal to set of all x such that x, y belongs to R. Here, this is and this and this. So, the domain of R is equal to 1, 2, 3. And the range of R is equal to set of all y such that x, y belongs to R. Then R is equal, range of R is equal to 6, 4, 2. That is 2, 6, 4. Okay. Now, we will discuss a very important question for CBSE student. Let A is a set of all x belongs to the set of integers such that 0 less than or equal to x and less than or equal to 12. So that a relation R set of all a comma b such that modulus a minus b is divisible by 4 for all a comma b belongs to set of integers is an equivalence relation, and find the set of all elements related to 1 and also write the equivalence class of 2. Okay. We have to show that R is an equivalence relation. What is equivalence relation? A relation R is said to be equivalent relation if it is recursive, symmetric, and transitive. So, we have to prove this is recursive, symmetric, and transitive. First of all, for recursive, let A be any element of the set A, that is A belongs to A. Then we can clearly say that modulus A minus A is equal to 0 and 0 is divisible by 4. That which implies that for all A comma A belongs to R, for all A belongs to R. So, R is the reflexive relation. Okay. Now, we will discuss the next part of the problem. For symmetric, suppose that A comma B belongs to A such that A comma B belongs to R. Then, modulus A minus B is divisible by 4. It is given. So, which is implies that B minus A is divisible by 4. We know that modulus A minus B is equal to modulus B minus A. This is the modulus A minus B is divisible by 4, which is implies that modulus B minus A is divisible by 4. That is B comma A belongs to R. Then we have for all A comma B belongs to R implies that B comma A belongs to R. So, hence R is symmetric. Okay. For transitive, suppose that A, B, C belongs to A, set of A, such that A comma B belongs to R and B comma C belongs to R. Since A comma B belongs to R, so modulus A minus B is divisible by 4 and B comma C belongs to R, so modulus B minus C is divisible by 4. Now we have modulus of A minus B plus B minus C. We know that if modulus modulus A is divisible by n and modulus B is divisible by n, then modulus of A plus B is divisible by n. Okay, so modulus of A minus B plus B minus C is divisible by 4. Minus B plus B out, so modulus of A minus C is divisible by 4. That is A comma C belongs to R. Then we have for all A comma B and B comma C belongs to R, which is implies that A comma C belongs to R. So R is transitive. Then we have R is reflexive, symmetric as well as transitive. Hence, R is an equivalence relation. Okay. Next, we find the equivalence class of 1 and 2. Okay. What is equivalence class? This is very important topic. Equivalence class. The equivalent class of an element A is denoted by box A and is defined by box A is equal to set up all B such that A comma B is satisfied the condition of the particular relation. A comma B must be satisfied the particular condition. Okay. If you want to write the set A in roster form, then we have A is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. Set of A is equal to set of all x such that 0 less than or equal to x less than or equal to 2. We have to find the equivalence class of 1. Here we see that the condition is modulus A minus B is divisible by 4. If we check the set A is, then we have 1 to 5, that is 5 minus 1 is equal to 4, which is divisible by 4. So the equivalence class of 1 is 1. 1 minus 1 is 0, 0 is divisible by 4, so 1. 5 and 1 minus 9 is equal to modulus 1 minus 9 is equal to 8 and 8 is divisible by 4, so we have 9. Hence, the equivalence class of 1 is equal to 1, 5, 9. Okay. If we check 1 to 6, then it becomes modulus of 1 minus 6 is equal to 5, which is not divisible by 4. So, 6 is not equivalent class of 1. Okay. Again, the equivalence class of 2 is equal to box 2 is equal to 2. 2 minus 2 is equal to 0 and 0 is divisible by 4. So, we have 2. 2 minus 6. 2 minus 6 is equal to 4 and 4 is divisible by 4. So, the equivalence class of 2 is 6. Okay. And 2 minus 10. 2 minus 10 is equal to minus modulus of 2 minus 10 is equal to 8 and 8 is divisible by 4. So, equivalent class of 2 is equal to 10. Okay. If we take 11, then we have 2 minus 11 is equal to 9 and 9 is not divisible by 4. So, 11 is not an equivalent class of 2. Okay. That's all for today. We will meet again in next class. Thank you everyone.